Imagine a canvas of unimaginable vastness, a sea of darkness speckled with the faint glow of distant stars. This is the universe, a boundless expanse, where the story of creation unfolds in the most spectacular ways. Each tiny dot of light represents a star, a beacon of energy and life in the cold void of space. This is the interstellar medium, the space between stars, a realm of cold, diffuse gas and dust. It is a seemingly empty void, but in reality, it is teeming with the raw materials of creation. These particles, though sparse, hold the potential to form entire star systems. It is from this unassuming canvas that our story begins, with the birth of a nebula, a cosmic cloud destined to become our solar system. Nebulas are the cradles of stars, the nurseries where new celestial bodies are born. They're vast, colourful clouds of gas and dust, illuminated by the light of young stars forming within them. Nebulas, these interstellar nurseries, are born from the death throes of stars. When a star reaches the end of its life, it can no longer sustain the nuclear reactions that fuel it. The star collapses under its own gravity, leading to a dramatic and violent end. When massive stars exhaust their nuclear fuel, they explode as supernovae, scattering their enriched guts across the cosmos. These explosions are among the most powerful events in the universe, releasing more energy in a few seconds than our sun will emit in its entire lifetime. These stellar remnants, enriched with heavy elements forged in the hearts of dying stars, seed the interstellar medium, providing the raw materials for new generations of stars and planets. The elements scattered by supernovae include carbon, oxygen, and iron, the building blocks of life as we know it. Our own solar nebula, a swirling mass of hydrogen, helium, and a smattering of heavier elements, was likely formed from the remnants of multiple supernovae. This nebula began to collapse under its own gravity, spinning faster and flattening into a disk as it did so. These stellar explosions, cataclysmic events that briefly outshone entire galaxies, left behind the building blocks of our solar system, the atoms that would eventually make up everything from the sun to our own bodies. The process of star formation is a delicate balance of forces, with gravity pulling matter together and pressure pushing it apart. This swirling cloud of gas and dust, a chaotic yet beautiful mess, was the starting point of our cosmic journey, a journey that would lead to the formation of our sun, our Earth, and ultimately ourselves. Over millions of years, the nebula continued to collapse and spin, eventually forming a hot, dense core that would ignite to become our sun. The remaining material coalesced into planets, moons, and other celestial bodies, creating the diverse and dynamic solar system we call home. Our solar nebula, a vast diffuse cloud, existed in a delicate equilibrium, the outward pressure of its own heat counterbalanced by the inward pull of its own gravity. This balance was a fragile dance, a cosmic ballet that had persisted for eons, with each particle of gas and dust playing its part in maintaining the status quo. However, this equilibrium was not to last. The universe is a dynamic place full of unpredictable events and forces. A disturbance, perhaps the shockwave from a nearby supernova or the gravitational nudge from a passing star, upset the balance, causing the nebula to begin its slow, inexorable collapse. This disturbance was like a cosmic domino effect, setting off a chain reaction that would ultimately lead to the birth of our solar system. As the nebula contracted, its rotation accelerated, a consequence of the conservation of angular momentum. This principle, a fundamental law of physics, dictates that as the nebula's radius decreased, its rotational speed had to increase to conserve angular momentum. Imagine a figure skater pulling in their arms as they spin. The tighter they pull, the faster they rotate. This analogy helps us visualize the dramatic increase in rotational speed as the nebula shrank. Similarly, as the nebula shrank, it spun faster and faster, transforming from a formless cloud into a rotating disk of gas and dust. This disk, known as a protoplanetary disk, was the nursery of our solar system, where planets, moons, and other celestial bodies would eventually form. At the heart of this swirling disk, gravity relentlessly drew matter inward, increasing the density and temperature at the center. This process was akin to a cosmic pressure cooker, with gravity acting as the heat source, compressing the gas and dust into an ever smaller volume. The once dark nebula began to glow, a faint ember in the vastness of space. This glow was the first sign of the incredible transformations taking place within the nebula, as the increasing temperature caused the gas to emit light. Over millions of years, the core of the collapsing nebula grew hotter and denser, eventually reaching temperatures and pressures unimaginable on Earth. These extreme conditions were necessary for the next stage of the nebula's evolution. It was within this inferno, this crucible of cosmic creation, that the heart of our solar system, our Sun, ignited. The ignition of the Sun was a monumental event, marking the birth of a new star. Nuclear fusion, the process that powers the stars, began in the Sun's core, releasing unimaginable amounts of energy and bathing the surrounding disk in light and heat. This fusion process involved the merging of hydrogen atoms to form helium, releasing vast amounts of energy in the process. The Sun, our very own star, was born. Its light and heat would go on to shape the formation of the planets and other bodies in our solar system, creating the environment necessary for life to eventually emerge on Earth. With the ignition of the Sun, our solar system transformed from a collapsing cloud of gas and dust into a protoplanetary disk, a vast rotating disk of material that would eventually give birth to the planets, moons, and other celestial bodies we know today. This swirling vortex of material, bathed in the light and heat of our newborn star, was a dynamic and ever-changing environment. The intense radiation from the Sun began to influence the disk, causing the particles within it to interact in complex ways. This disk, a cosmic construction site, was where the planets, including our own Earth, would be born. It was a place of constant motion and transformation, where dust and gas were gradually coalescing into larger and more complex structures. Within the disk, a delicate dance between gravity, heat, and centrifugal force shaped the destiny of the solar system. Gravity pulled particles together, while heat from the Sun caused some materials to vaporize and others to solidify, depending on their distance from the star. Close to the Sun, where temperatures were scorching, only heavier elements like rock and metal could condense into solid grains. These materials began to form the building blocks of the inner planets, including Mercury, Venus, Earth, and Mars. Further out, beyond the frost line, temperatures were cold enough for ices like water and methane to solidify, adding to the mix of available building blocks. This region would eventually give rise to the gas giants and icy bodies of the outer solar system. These tiny grains of dust and ice, remnants of ancient stars, swirled and collided within the disk. Each collision was a chance for particles to stick together, gradually growing larger over time. Most collisions resulted in glancing blows or shattered fragments, but occasionally particles stuck together, their mutual gravity pulling them into a cosmic embrace. These small clumps began to attract more material, growing ever larger. Over time, these clumps grew larger, forming larger and larger aggregates known as planetesimals, the seeds of planets. These planetesimals continued to collide and merge, eventually forming the protoplanets that would become the planets we see today. The protoplanetary disk, a chaotic yet creative environment, was a breeding ground for planets. It was a place where the forces of nature worked together to create the diverse array of worlds that populate our solar system. This cosmic nursery, where worlds were born from the dust and ice scattered by long-dead stars, was a testament to the incredible processes that shaped the universe. Each planet, moon, and asteroid in our solar system is a product of this ancient and ongoing dance of creation. As planetesimals grew larger, their gravitational pull increased, attracting more and more material from the surrounding disk. This process, known as accretion, led to a runaway effect, with the largest planetesimals growing at an accelerating rate, sweeping up gas and dust like cosmic vacuum cleaners. In the inner solar system, close to the Sun, the intense heat and solar wind blew away most of the lighter elements, leaving behind a realm dominated by rocky materials. Here, The terrestrial planets, Mercury, Venus, Earth and Mars, formed relatively small, dense worlds composed primarily of rock and metal. Further out, beyond the frost line, where temperatures were frigid, icy planetesimals reigned supreme. Here, the gas giants Jupiter, Saturn, Uranus and Neptune formed colossal worlds with massive atmospheres composed primarily of hydrogen and helium, the most abundant elements in the universe. The formation of the planets was a chaotic and violent process, a cosmic billiards game where collisions were commonplace. Planetesimals collided and merged, their orbits intersecting in a celestial ballet choreographed by gravity. Some collisions were catastrophic, shattering worlds apart, while others resulted in the formation of moons or the tilting of planetary axes.